Hello, this is Praveen Kumar. My topic is anti-knock additives in SI engines, and my branch is mechanical engineering. Here, the content is introduction, rating of fuel, formula, laboratory, method, conclusion, reference. So first we will go with the introduction. So there are two important parameters that rate the engine fuels. Those are octane number for the petrol, centane number for diesel. Usually the rating of the fuels will done by their anti-knock characteristics, and the rating of spark ignition engine fuels. Anti-knocking is one of the major characteristics for the spark ignition engine fuel. The resistance to the knocking is completely dependent on the chemical composition of the fuel. Apart from these are other parameters which result in knocking in the spark ignition engine. Those are the air fuel ratio, ignition timing, engine speed. Dilution, the shape of the combustion chamber, compression ratio, ambient conditions. So before we rate the anti-knock characteristics of the fuel, we have to fix those parameters to the standard values. Now normally fuels are rated for their anti-knock characteristics. So we have to determine the anti-knock characteristics for any fuel. It can be done by comparing it anti-knock property with a mixture of two reference fuels. One which is having the high octane number and another one which will have less octane number. So isooctane C8H18 is rich in the octane. It is around 100 as the octane number. On the other hand, the normal heptane C7H16 has 0 as the octane number. These two are used as reference fuels to determine the anti-knock characteristics. So rating of fuels, spark ignition and compression ignition. The octane number of a fuel is defined as the percentage by the volume of the isooctane in the mixture of isooctane and the normal heptane, which will exactly match the knocking intensity of the test fuel in a standard engine under the standard operating condition. So the addition of the certain compounds such as the tetraethyl lead to the isooctane will result in the fuel with a greater anti-knock property. So at the high range octane number, we have even a small change in the octane number brings greater anti-knock property. So for example, the octane number increases from 92 to 93 will result in the greater anti-knock property than the octane number increasing from 30 to 31. Due to this progressive character of the octane number, so the effectiveness on the anti-knock property, so there is a new scale derived to express the octane number relative to the performance of the engine. So octane number above 100 can be computed by using the following formula. Octane number ON is greater than 100 equal to 100 plus 28.28A by 1.0 plus 0.736A plus under root of 1.0 plus 0.76 amperes minus 0.035A square, where A is the amount of tetraethyl lead in the milliliters grams of fuel. In the other words, the octane number can be computed with performance number Pn by using the following formula. Octane number On equal to 100 plus Pn minus 100 by 3. So this is the laboratory method. A knock meter is used to measure the knocking in the engines. First of all we have to measure the standard knock in for the engine at the standard operating conditions. So the spark ignition engine will be run at specified conditions with the standard compression ratio and a definite composition of reference fuels, so that can measure the standard knock in the engines. Now put the fuel which needs to be tested into the engine. which needs to be tested into the engine, and the air fuel ratio needs to be adjusted to get the maximum knock in the engine. The worst case scenario, now the compression of the engine needs to be adjusted to bring down the knock meter reading to the match the standard knocking readings. So now the compression ratio is fixed and the composition of the reference fuel is known, which means we have matched the knocking produced by the reference fuels in the engine with the knocking produced by test fuel. So the percentage by volume of isooctane with the particular composition of reference fuel gives the octane number. So rating of compression ignition engine fuels. In the compression ignition engines, the anti-knock characteristics will depend on the chemical composition and also on the design and operating conditions of the engine. So the knock rating is done by the comparing the fuel under pres- prescribed condition of operations in a special engine with the reference fuels. The reference fuels are normal as centane C16H34 having the centane number as 100, and the second one is alpha methylnaphthalene C11H10 having the centane number as 0. The centane number is defined as a percentage by the volume of the normal centane in the mixture of normal centane and the alpha methyl naphthalene, which will exactly match the ignition characteristics of the test fuel in a standard engine under the standard operating conditions. Since the ignition delay is the main character that can control auto ignition in the compression ignition engines, so this character can be helpful to conclude the knock character in the CI engines, which means the ignition delay is directly related to the knock character. Adding of the amyl nitrate, ethyl nitrate, or ether can improve anti-knock characteristics. So the laboratory method. This test must be carried out under certain operating conditions shown in the below table with the single cylinder such as CFR, defined as cooperative fuel research, diesel engine, or Ricardo single cylinder variable compression engine. First, the test fuel is used in the engine at the specified operating conditions. The fuel injection delivery pump also need to be adjusted to give a correct fuel air ratio. Engine speed 900 rpm, jacket water temperature 100 degrees Celsius, inlet air temperature 65.5 degrees Celsius, fuel injection advance constant at 13 degrees before TDC, ignition delay 13 degrees. The fuel injection timing needs to be set to 13 degrees before the top dead center. Now we have to find the position for the ignition at the TDC to get the ignition delay by 13 degrees by varying the compression ratio. Now centane number can be found by noting down the compression ratio at which the ignition delay is 13 degrees. So as we said earlier, the ignition delay is directly related to the knock character in the combustion engines. The centane number of the unknown fuel can be estimated by noting down the compression ratio of 13 degrees and then referring to a prepared chart shown in the relationship between centane number and the combustion ratio. So however, the accuracy to reference fuel compositions differing by not more than 5 centane numbers are selected to bracket the unknown sample. The compression ratio is varied for each reference blend to reach the standard ignition delay. And by interpolation of the compression ratios, the centane rating of the unknown fuel is determined. So the conclusion, we have discussed the rating of fuels for both the spark ignition engine fuels and for the compression ignition engine fuels with the traditional method and the laboratory example. So reference school YouTube. Thank you.